Welcome to this predicted paper from onmaths that is based on the advanced information given to us by the exam boards. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. If I split this shape into two sets of 6 blocks, when we're asked to shade in 3/6, for each one of those, or each set of blocks, I'm going to shade in 3 of the 6. So that's 3 for the first set, and this is 3 for the second set. And that's our answer. Now you might notice that 3/6 is the same as a half, because we can divide on 1 by 3, and so all I need to do is shade in a half. Or you might convert 3/6 into 6/12, and there's 12 squares altogether, so it's 6 of the 12 squares. There's lots of ways of doing this question. If there were 39 people on the bus and 4 people got off the bus, that would leave 35 people remaining on the bus. So the fraction of people staying on the bus is 35 out of the 39 people on the bus. So our answer is, as a fraction, 35/39. We can't cancel that any further. To find if a fraction is equivalent to a quarter, you can multiply the numerator by 4, and it should match the denominator. So 1 times 4 is 4, and that matches the 4 at the bottom. So 3 times 4 for this first fraction is 12, well that doesn't match. 4 times 4 here is 16, well that doesn't match. 12 times 4 here is 48, that doesn't match. 2 times 4 is 8, so that does match. So our first answer is D. And let's see if there's a match for our last one, which hopefully there is. 8 times 4 is 32, so there is a match for our last one as well. So those are the two fractions. If we tried to draw a quadrilateral with a pair of parallel sides, and then it's a quadrilateral, so join them up, it's got 4 sides, then the shape we draw will always be a trapezium. So our answer is that it is a trapezium. Now you might think that a rectangle and square does have one pair of parallel sides, but it actually has 2 pairs of parallel sides. The definition of a trapezium is it has just one pair of parallel sides, and any quadrilateral that has one pair of parallel sides is a trapezium. Whenever we multiply 2 negatives, we always get a positive, so we know our answer will be positive. We're going to do 9 times 12, which is going to be 108, and v times v, which is going to be v squared. So we're just going to start by writing the number a little bit bigger. So it says 2 decimal places, so we're going to draw a line after the second decimal place. Now all the numbers to the right are going to disappear, they're going to turn to 0, and because it's a decimal that just means we get rid of them. But we have to look at this number first. Now if this number is less than 5, we just keep the number to the left, so 8.17. But if it's 5 or more, then this 7 goes up to an 8. So this will be 8.18. To find a coordinate, what we can do is we can start in the middle and we work out how far across we have to go. And here we have to go 2 across, so the x coordinate is 2. Then we find out how far upwards or downwards we have to go. And here we can go, well, we have to go 3 downwards, so that's going to be -3. So we first of all look at the x coordinate, the 2, then the y coordinate, -3, along the corridor, up, or in this case down the stairs. A comparative bar chart is where you have 2 bars next to each other meaning different things. So it's probably easier just to start drawing it, and then we can talk about it as we go along. So we've got males here at 12, and so what we want to do is a bar that is 12 high, and these are going up in 2s. So it will be up here. There we go. And then right next to it, we're going to do females, which is 14. And so what we're going to do is we're going to make this go up to 14. And there we go. Now, we need to be able to tell these apart. So what I'm going to do is just shade in the females. And we should do a little key. And we say that if they're not shaded, it's males. And if they're shaded, that is females. Okay, let's carry on with the bar chart. So it's 14 and 6. So notice I've got gaps between the pairs. So we've got 14 and 6, which will be down here. And again, we're just going to shade in the females. And then finally, we've got 8 and 16. So 8 would be here, then 16 would be up here, and finally obviously we're going to shade in the females. So we're going to start off by writing the sequence out, and what you might notice straight away is that each of the terms is increased by 2. And so we're asked to find the next 2 terms. So we're just going to keep this pattern going. So increase it by 2, that would be 20. Increase by 2 again, and that would be 22. So we're going to start by writing 5 over 9 as a decimal. And to do that, we just need to do 5 divided by 9, which will be 0.5 recurring. And to convert between a decimal and a percentage, we just times by 100. So we're going to get that 0.5 recurring, and we're going to times it by 100, and that will equal 55.555 recurring. And to the nearest percent, that's going to be 56, because that 5 will move that 5 up by 1. So we can either use the calculator to work out what 1.2 cubed is, or we can do 1.2 times 1.2 times 1.2. Now if you want to use the calculator to go straight there, you're going to press or type in 1.2, and then normally there's a button that looks like this, X with a little 3, okay, and that will give you the answer. Or if you're not sure how to do that, you can times it by itself 3 times, and you get the answer 1.728. I'm going to start just by writing down the number. And we're asked to round this to 3 significant figures. And basically what that means is starting from the left-hand side, it's 3 numbers that we want. So 1, 2, 3. And we're going to do our line after that third number. And you start counting the first non-zero digit. So the first digit there was 2, so we started counting. Now all the numbers to the left, or sorry, to the right, so these numbers here, will all turn to 0. But before that happens, we look at this number. Now this number, if it's 5 or more, it moves this number up by 1. If it's less than 5, that number stays the same. Now it is 5 or more, because it is 5. So it's not going to be 207, it's going to be 208. Now, a common mistake is that students write down 208. No. All the numbers to the right of that line turn to 0. So it would be 0, 0, 0. So it would be 20,000 or 208,000 exactly. So a composite bar chart is where you'll stack the bar charts on top of each other. So we're going to start with this 12 here. And so I'm just going to do a bar up to 12. And these lines go up in 2s, so it would be there. And then we're going to do this females. So we've done the males, we're going to do the females. And the females is only going to be 1 high, because they're going up in 2s. And we need a way of showing male or female. So what I'm going to do is just shade the female there, and I'm going to just draw a key. I'm going to say if it's not shaded, it's males. And if it is shaded, it's females. Okay, Next we're going to do the 8 and the 4. So what you can do is just do the whole thing, then split it afterwards. So it would be like that. Shade in the females. And then finally we've got a 4 and a 12. And let's shade in the females there. Now don't spend forever on your shading, as long as it's clear which one's male and which one's female. When collecting terms, you've got to collect like terms. So we've got 13x, we've got a 3y. Now they're not like terms, but the 13x is a like term to the 7x, they're both x's, and the 3y is a like term to the 2y. So let's put the x's together, 13 lots of x plus 7 lots of x. And let's put the y's together, 3 lots of y plus 2 lots of y. So altogether we've got 13 lots of x plus 7 lots of x. Well, that's going to be 20 lots of x. And for the y's we've got 3 lots of y plus 2 lots of y. That's going to be 5 lots of y. So our answer is 20x plus 5y. There are a number of different ways of working out this question. You can find out the amount of tissues per penny. You can work out the amount of or the price of one tissue, or you can get all the amount of tissues into the same amount. I'm going to find out the price per one tissue, and we're going to start off with the 24. And what I'm going to do is I'm going to convert the money into pence, just to mean that we don't have as much decimal. And we're going to do 807. I'm going to divide by the 24 to find out the price of one tissue. So that is 33.625, and so I'm just going to round that to 33.63. I'm just going to round everything to 2 decimal places, which says in the question. Next one, we're going to do the 20 soft tissues. So this time I'm going to do 683 divided by 20. When I put that into the calculator, you get 34.15, so that's already 2 decimal places. And then finally we're going to do the 15 soft tissues. So we're going to do the 623 divided by 15 to find the price per tissue. It should be 41.533 blah blah blah. And rounded would be 41.53. So if you buy 15 tissues, it will cost 41 pence. 20 tissues, it will be 34 pence per tissue. But 24 tissues will be 33.63. So that's by far the cheapest. The best value is the 24 tissues box. Now, there's such thing as buying in bulk. Generally, the more you buy of something, the cheaper it is. Don't rely on that. Both in the GCSE, both in the exam, and in real life. Sometimes in real life, if you buy more of an item, actually per tissue, sometimes it becomes more expensive, especially if there's a special offer on the smaller box. So we've got to first of all make these both the same units, because at the moment they are different units, and when we have ratios we always want to make sure that they have the same units, and then we can get rid of the units. So I'm just going to make them both into grams. I'm going to do that by times in the right by 1,000. And the reason I've chosen grams rather than kilograms is you want to always pick the smaller unit. Otherwise you'd be left with a decimal on the left hand side. You'd be 0.2, and that can be a bit more complicated. Okay, so I'm going to remove the units now, and we're just going to focus on the numbers. So we can divide both sides by 100 straight off the bat. So we've got 2 to 40. We can see we can divide them both by 2. And so we've got 1 to 20. And so it's 1 gram to 20 grams, or just 1 to 20. Here we're given a triangle, and we're not actually given the values of each of the angles. We're given them in terms of x, but we know that they're going to add up to 180. So we're going to do the 20x plus the 2x plus the 23x, and we know that it's going to equal 180, and the reason is that its angles in a triangle add up to 180. Okay, let's get our tramlines in. Because we've got algebra and we're solving here, we're going to put our tramlines in. Now on the left hand side we need to add these x terms together, so 2x plus 23x will be 25x, plus the 20 will be 45x. And what we're going to do to get x on its own, we're going to divide both sides by 45. So we're going to divide by 45 both sides, and we're going to end up with x equals 4. So to find the probability, we're going to do the successful outcomes divided by the total number of outcomes. So looking at this question, it says number of times it should land on a 1, so that would be 1 over the total amount, which is 11. So the chance of us getting a 1 is 1 over 11. To find the expected amount, we do the probability and we times it by the amount of trials. So it says it's spun 60 times, so we're going to times it by 60. And that will give us the answer of 5.454 blah blah blah. Now it can't have landed on a 1 5.4 times, so it's definitely, well, this probability, we always round down, so never ever round up, because it's 5 times and then a little bit extra, and so only when it gets to 6 can we say that it's 6 times. So the answer to this is just 5. To answer this question, we basically need to find the lowest common multiple of the 10 minutes here and the 15 minutes here. So we're going to start off just by doing the 10 and 15 times table. So it'd be 10, 20, 30, and 15 times table with 15 and 30. So the lowest common multiple is 30. So after half an hour, these buses will sync up. They'll both leave at the same time. And all buses start service at 9 o'clock. So it will be half an hour after 9 o'clock, which will be 9:30. We've got to first of all work out how many parts there are altogether in our ratio. So we've got 51 saying yes, 7 saying no, and 13 undecided. So altogether, we've got 51 plus 7 plus 13, which is 71 parts. Now each part is equal. So to find out the value of one part, we're going to do how many students there are, which is 2,911, and divide it by the 71 to find out what one part is worth. How many students are in one part? One part's worth 41 students. So each one of those parts in the ratio is 41 students. Now yes, because it goes yes, no, undecided, yes will be the 51 there. So it's 51 lots of 41 students. 51 parts with each part representing 41 students. And when you multiply those together, you get 2,091. So our answer is that 2,091 students responded with yes. So we're going to start off by filling out this table. So 0 times 1, 0 times 2, 0 times 3, 1 times those, 2 times those, and 3 times those. And we're looking for the probability that the product, which just means that when we times them together, will be more than 2. So which of these are more than 2? Let's circle all the ones that are more than 2. And to work out a probability, it's always the successful outcomes over the total amount. So the successful ones are the ones I've circled, so 1, 2, 3, 4, 5, 6, 7, 8, 9. The total are all of them together, where it's a 4 by 4 grid, so it'd be 16 in total. And so the probability that the product will be more than 2 will be 9/16. So we're going to start by doing a circle at -13 and a circle at -6. And x is between those values, so we're just going to join them up with a line. Probably move my circle down a little bit. Okay, next thing to do is figure out which of these dots are going to be filled in. So if it can equal that number, it gets filled in. So it can equal -13, so I'm going to fill that in. But for -6, it can't equal that, so it becomes a hollow dot. So looking at the hours and the charge, we know that 4 hours is a charge, and I'm going to do the charge in pence, of 1,980 pence. And so what I want to do is just work out what 1 is. And to do that, I'm going to divide that by 4. So I'm just going to divide this by 4. It's always useful to find out what 1 is first. So that would be 495. Then all I need to do now is times it by 15. Because 1 times 15 is 15. And so we've got 15 hours. And when I times that by 15, I get 7425. So it'd be £74.25. So we know that the mean is the sum of numbers over the amount. But in this question, we're actually given what the mean is. We're given that that is 29. We're also given the fact that there are 4 cards, so we're given the amount. So what we can do is just get our lines in and solve this. So what we're going to do is just times both sides by 4. So we're going to do 29 times 4, which is 116. And so we know that the sum of the numbers will be 116. So all we need to do is to find the 4th card, is get that 116 and just take away the numbers that we know. And when we do that, we get the answer 26. Now you can easily check this by adding up 37, 26, 27 and 26 again, and then dividing it by 4, and you will get 29. The first piece of information I'm going to focus on is the fact Denver gets 8/19. Denver gets 8/19, that means that Engel and Fido together must get 11/19 because they have to add up to 1. So we're only looking at 11/19. I'm going to focus on the ratio next of Engel to Fido. So it's 9/5. And let's have a look and see, well, first of all, how many parts there are all together. So 9 plus 5, which is 14 parts. So there are 14 parts in total, and the share that they get is 11/19. So what I'm going to do is to find out what fraction one of those parts is worth by dividing 11/19 by 14. So each part is worth, and I'm just going to keep this into my calculator, 0.041 blah blah blah. And we're asked to find Fido's share. Well, Fido has 5 parts. So Fido has 5 parts, each of them worth 0.041 blah blah blah. I've kept it in my calculator to keep the accuracy. And when I do that, I get 0.206 blah blah blah. Now we're asked to work it out as a percent, so I'm just going to times that by 100. So we have 20.676 blah 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 percent, and it wants it rounded to the nearest percent, so that would be 20%. Or actually, it would be 21%, because this would round it up, so 21%. So firstly, we're going to work out what the percentage increases are as a multiplier. So we start off with 100%. Jane has a 1.2% interest pay rise, and so that would be 100 and 1.2%, and we divide that by 100 to make it a multiplier. So the multiplier is 1.012. So we get the 20,000 times it by 1.012, and that gives us 240. Next we do the same for Lenny, so that is Jane. And so let's do Lenny. And so that's 100% plus the 1.5% will be 101.5%. Make that a multiplier, 101.5%. We divide that by 100, which gives us 1.015. And then finally what we do is we get the 17,000 times it by the multiplier. And when we do that, we get 255. So Lenny has 255, Jane has 240. So it says which of the employees has a larger pay increase and by how much. So the answer will be Lenny, and it's by £15 because that's the difference between these. The experimental probability is the successful outcomes divided by the total number of outcomes. So we're looking for the probability that it's white, so it's going to be 25 over, and we're just going to do 35 plus 25 plus 31, which is 91, and that's our probability, 25 over 91. Be careful when it say total, you must include all of the outcomes, so red, white, and other. There's a very specific way to draw a perpendicular from a line. What you do is you get a pair of compasses and measure roughly 3/4 of the way between A and B, and draw an arc from point A, and we're going to draw an arc from point B. And you can see that the two arcs intersect here and here. So what we're going to do is just draw a straight line that join up where they intersect. Leave your workings out, your arcs, on the page when you do this to make sure you get full marks. There are two rules for things to be in direct proportion. The first rule is you must have a straight line, which we do on this question. The second rule is it must go through the origin. So we're looking for a line like this or like that, somewhere in that region there. Now, this red line does not go through the origin, so A and B cannot be in direct proportion. Factorising is the opposite of expanding. So instead of removing things from a bracket, we're actually putting them in a bracket. And so we're going to start off by just putting the bracket down. And we're going to think, well, what can we put on the outside? So we look at the 20x squared and the 35x. And we first of all think of the number. So we're looking for the biggest number that goes into 20 and 35. Essentially, its highest common factor. Well, that's going to be 5. And then we look at the letters. So we look at the most amount of letters we can divide out. Well, this only has an x here, so it's just going to be an x. Then what we're going to need to ask ourselves is 5x times what is 20x squared? Well, 5 times 4 is 20, and x times x is x squared. Then to get the second term in the bracket, we ask ourselves, what times 5 is 35? Well, that's going to be 7. And what times x is x? Well, we don't need an x on the end of that. 5x times 7 is 35x. And you can actually expand that, and you can use any method you want, but I'll use Smiles and Rainbows. And so we're going to do 5x times 4x, which is 20x squared, and 5x times 7, which is 35x. So our answer will be 5x brackets 4x plus 7. So we're just going to substitute the values that were given into the formula. So v squared equals, and then u is 16.4 squared plus 2 times a, which is 0.2, times s, which is 110.2. Type that into the calculator and you get 313.039 blah blah blah. And what we're going to do is we're just going to quickly solve this by square rooting both sides, because it's v squared equals and we just want v equals. So v equals, and we're just going to square root that on the calculator, 17.692 blah blah blah. It says it wants it to 2 decimal places, so that's just going to be 17.69. So we're told that y is directly proportional to x. And so the first thing I'm going to do is replace that proportionality sign with an equals, and to do that we need to introduce k. So y equals kx. So you just multiply the right hand side by k. Then I'm going to substitute the values it's given us. So it says to us that when x is 5, y is 4.5. So when y is 4.5, and then we've got x is 5. Then I'm just going to quickly solve that. Get my lines in and divide both sides by 5, and so that's going to be 0.9 equals k. So k is 0.9. So I go back to the equation, and instead of y equals kx, I know that y equals 0.9x. Now k is a constant, which means it will never change, so it's always going to be 0.9. So to find the value of x when y is 5.4, I'm just going to replace y with 5.4, and just a matter of solving again. So get my lines in, and what I'm going to do is just divide both sides by the 0.9 to find out what x is. And when I do that, I find that x is 6. There's a very specific way to draw an angle bisector, and you start off with a pair of compasses and put the point on B, and then draw an arc from B. And it doesn't matter what the distance is, as long as it's kind of roughly maybe halfway between A and B. It doesn't matter what the distance is. And then at the 2 points, so here and here, that our arc intersects line AB and BC, we're going to draw another arc up here. So I'm just going to show you, because it's normally easier. So an arc over here, and I'm going to do an arc from the other one over here. Then what I'm going to do is I'm going to join where the 2 lines join with where the 2 arcs join. And that is how you do an angle bisector. All of the arcs leave on the diagram because they are going to get you the marks. Arcs for marks. So the only way of answering this question is to work out what these are as ordinary numbers. And so 7 times 10 to the power of 7 would be 7, 1, 2, 3, 4, 5, 6, 7. And 9 times 10 to the power of 4 would be 90,000. So that would be 9, 0, 0, 0, 0. And so we're just subtracting them like that. And so we'll get 6, 9, 9, 1, 0, 0, 0, 0. And obviously if this is on the calculator paper, just type it into your calculator. There are no tricks here. You can't do anything with the 7 and the 9. You're not subtracting powers or anything. You're just literally typing in what it says. And there's a button on the calculator like that you will need to use. So if you don't know what that is, ask your teacher or ask someone to help you out with that. So when you read this question, the question's basically asking you to find the bearing of O from B. So the lifeboat is at B, so I'm going to draw a north line here. And to find a bearing, you start from the north line and you keep going clockwise. So we're going to look for this angle here. Now, this angle, which is given to us in the question, and this angle here, which I'm just going to call x, are going to be equal. So x is going to equal 135 degrees. And the reason for that is we've basically got, and I'm just going to draw or extend the north line down, because we've basically got we have a set of parallel lines here, and we have a set of z angles, which we know is alternate angles. So the reason for that is it's alternate angles. And always show the reasons to the examiner. Okay, and so to find out what the bearing is, so the bearing of O from B, it's just going to be 360 take away 135. And the reason for that is angles on a point. We've run out of space. Okay, so we're going to do 360 take away 135, which is 225. And so our answer is 225. So if we imagine we've got the 25 meter pipe here, and we've got the 35 meter pipe here, the question's basically asking us what can we cut all these pipes into, and they all have to be the same length that will fit with the 25 meter and the 35 meter. And essentially what this question is asking is, what is the highest common factor of 25 and 35? So to find the highest common factor, what we do is we just find the factors of 25, which is 1 and 25 and 5 and 5, and the factors of 35, which will be 1 and 35 and 5 and 7. And the highest common factor is the number in both lists, the highest number in both lists, so it's 5. So what we can do is we can cut all of these pipes into 5 meter pipes. So 1, 2, 3, 4, not to scale, and then 7 of these, so 1, 2, 4, 5, 6. And so there's 7 in total. So each of these are 5 meter long, and there's no wastage. And that's the longest we can make the pipes for there to be no wastage at all. So my answer is 5 meters. To work out the mass, we will need to find the density and the volume. Density is given to us in the question, but volume isn't. So we need to work out what the volume of this cuboid is. So the volume is just the 33 times the 7 times the 22. So that would be 5,082, and that would be centimeters cubed. And we need to write down the formula for density. So density is the mass divided by the volume. So rearrange this to get mass on its own, because that's the thing we're looking for. So mass equals density times volume. Density is given to us in the question as 2.1 grams per centimeters cubed. Times that by the 5,082 for the volume, and we get the answer of 10,672. And then that will give us grams, because our density is in grams, so that is grams, but the answer is asking for kilograms. So to convert that to kilograms, we just divide by 1,000, and we get 10.672. Then we need to round that to 2 decimal places, and so that would be 10.67 kilograms. So I'm going to start just by writing out the equation, and I can put my lines in. Okay, we're asked to make x the subject, so we're going to first of all add 10 to both sides. In fact, I'm just going to move all this over a little bit so I've got a bit more space. Okay, so we're left with m plus 10 on the left hand side, and we've got 1/7 x on the right hand side. Now to get rid of the 1/7, what I can do is just times both sides by 7. So 7 brackets m plus 10 equals x. So x therefore would equal 7 brackets m plus 10, but it says expand your answer fully, so we're just going to expand the brackets. 7m plus 70. This looks like it's a really tricky question, and it is a little bit tricky, but it's a little bit easier than maybe it looks. The highest common factor is found when you have the prime factors, which we do, of two numbers, and you put them into a Venn diagram. Then you can find the prime factor, the highest common factor, by multiplying all the numbers in the overlap. So we're going to rewrite these numbers. Just instead of squared, we're just going to write them out without index form. Just makes it a bit easier. And so I'm just removing the squares, and we're going to draw ourselves a Venn diagram. So let's just do a rectangle at the outside. I'm going to try and do some nice circles here. Try my best anyway. Okay, so on the left hand side we have the 450, on the right hand side we have the 132. So we'll start with the 450 and the numbers. So actually looking at the numbers, looking at the factors at the top, the prime factors, we can see they both have a 2 in them, so I cross them both out and put 2 in the middle. We can see they both have a 3 in them, so cross those 3's out and put 3 in the middle. And then 450 has a 3, a 5 and a 5, and 132 has the 2 and the 11. So to find the highest common factor, as I said, you multiply all the numbers that are in the middle, and so the highest common factor will be 6. So this question says that Adrian, Ben and Charlie have some sweets, and the ratio of Adrian to Ben to Charlie is 9 to 6 to 13. But it also says that Charlie got 56 more sweets than Adrian. So there's 56 more sweets. Well, looking at the actual parts of the ratio, there are 4 more parts. So plus 4 parts, which represent plus 56 sweets. So the 4 extra parts are worth 56 sweets. So 4 parts are worth 56 sweets. So 1 part would be 56 divided by 4, which is 14 sweets. So all we need to do now is work out how many parts there are. Well, there are 9 plus 6 plus 13 parts, which is 28. And each part is worth 14 sweets. So the total number of sweets will be 28 times 14. So 28 times 14 is 392. So to find the locus of points that are 10 centimeters away from a point, you need to measure 10 centimeters on a pair of compasses, and then you put the point at A and draw them. Now I'm going to try my best to do this. It's probably not going to look perfect, but I'll do my best. And the length here, which is supposed to be, probably isn't exactly, but this part here is going to be 10 centimeters to get the full marks, and obviously you want the circle to be a little bit nicer than the one I've drawn, but try and get it as perfect as you can. And the best way of doing that is just don't push down too much and just move the page around with your compass being stationary. We're going to start by focusing on the A and B, which is 8 and 16, so in the middle is going to be 8 and 16. The next thing we're going to focus on is the fact that A is all the multiples of 4. Now 8 and 16 have both already been taken because they're in the middle. So the remaining multiples of 4 are the 4 there and the 12 there. So the next ones I'm going to focus on is the A or B. So A or B is in A, in B, or in the middle. So if we cross out the ones we've already used, so we've already used the 8 and 16 and the 4 and the 12, that leaves the 1 and the 9. We'll cross that out of our other list. And there's only 2 left in our everything list at the top. We've got the 3 and we've got the 11. So on the outside we have 3 and we have 11. Okay, so we're going to start off by working out the multiplier, and we're told, we always start off with 100%, we're told that the compound interest rate is 1.6%. So we're going to add 1.6% to the 100%, and it's going to be 101.6%. Okay, make that into a decimal by dividing it by 100. So we're just going to divide that by 100, and this will give us the decimal or the multiplier. So the multiplier is 1.016. And so anytime we want to increase something by 1.6%, we just times it by 1.016. Now, we're told that we start off with 2,400. That's our original amount. And to find out what it's going to be in the savings account at the end of the first year, we just times it by the multiplier, 1.016. But we're told that it's for 7 years that it's going to be in there. So we then times it by 1.0167 times, or easier way of doing it is 1.016 to the power of 7. When we do that, we get 2,682.052 blah blah blah, and because it's money we round to the nearest pence, so 2,682.05. So here we're given a standard form number, and we're asked to make it an ordinary number, which is just a number you type into the calculator. So we're going to start off by writing the decimal, which is 6.2, and we're going to shift that decimal point somewhere that it will be the actual number rather than standard form anymore. First thing to point out is we look at the power. If it's positive, it means that our ordinary number is going to be a big number. If it's negative, it means it's going to be a very small number. Since this is positive, we know it's going to be a big number. So we're going to do 4 jumps, because there's a power of 4, to the right to make it a big number. So 1, 2, 3, 4. So the decimal point is going to be here. And we're going to fill in the jumps with zeros. So 0, 0, 0. So our new number is going to be 62 with 3 zeros, or 62,000. Now it's important to realise that we're actually shifting the numbers, not the decimal point, but it's a lot easier to move the decimal point in our working out. So we've got to first of all understand what standard form is, and standard form is a number that is between 1 and 10, but not including 10, times 10 to the power of another number. So to find out what the number is going to be for our standard form, we're going to just write down the decimal first, so 0.098, and we've got to put a decimal point in somewhere to make this a number between 1 and 10. So if I put it in here, that would make it 9.8, and we're ignoring the zeros to the left-hand side. So we know that our standard form is going to start off with 9.8 times 10 to the power of something. Now this times 10 is always going to be there. It's never divided by 10 or anything like that. It's always times 10. Next, we've got to find out what the power is going to be. So first of all, if it's a small number, if it's a number less than 1, which this is, it's a small number, it's going to be a negative power. And the next thing we do is work out how many jumps we had to do. So it would be 1, 2 jumps between where the decimal point was and where it is now. So 2 jumps means it's going to be to the power of -2. So we're asked to find the bearing of Freetown from Gamley. So that is this angle here. And so what we're going to do is we're going to find this angle, and this will obviously be 90 degrees because the hiker walked west, and it's against the west line and the north line, so it's definitely 90 degrees. So we can work out what the bearing is if we know that angle inside the triangle. So we're going to start by labelling the sides. Well, we've got a 90 degrees here, we've got hypotenuse here, we've got the adjacent here next to the angle, and we've got the opposite, which is across from the marked angle. Here we're not using the hypotenuse, so we can cross that out. And we can do our SOHCAHTOA. And the only one that doesn't have the hypotenuse is TOA. And so we're doing tan x equals the opposite, which is 49 over 98. Get our lines in. And we're going to do the inverse tan to both sides. So we get x equals, and we do inverse tan, which is 26.565, blah, blah, blah. Okay, so we know that the whole of the way around up until this point is 270 because we've got this 90 degree left. So what I'm going to do now is we're just going to work out the bearing. So bearing, we're just going to do 270, take away the 26.565, blah, blah, blah. And that gives us 243.434, blah, blah, blah. It says it wants it to the nearest whole number, so that's going to be 243. So we're going to start off by finding the multiplier, and we start off with 100%. It's an increase of 3.4%, so we're going to increase 3.4%, and so that would be 103.4%. And then we need to make that a multiplier, so we're dividing it by 100. And so that would be 1.034. So anytime we times a number by 1.034, we'll increase it by 3.4%. So it says that we start off with 1,700. So what we're going to do is we're going to type in 1,700 into our calculator, then we're going to press the equals button. And what that does is it stores the 1,700 in memory. Then, every time we press the A and S button, it's going to remember what the current number is, and we're going to then times that by 1.034. So at the moment, the current number stored in memory is the 1,700, times by 1.034 will increase the 1,700 by 3.4. Press it once, and it gives us £1,757.80. Now, when we press it again, that would be after the second year. So it puts in the 1,757.80, it puts that in as this answer here, and then raises that by 3.4%. So we've got to keep pressing equals and count how many times we press equals to get to £1,743.26. And you'll find that on the fourth press of the equals button, you will get £1,943.26. So this question is a simultaneous equations question. And so we're going to have to write down some equations. So it says 2 apples and 3 pears cost £3.80. So 2 apples, I'm going to call it A for the price of an apple, plus 3 pears, so 3p, cost £3.80. Now I'm going to do this as 380 just because it's easier to work with integers rather than decimals. And it says 3 apples, so 3a, plus 8 pears costs £7.80. Or 780 pence. Okay, so the first thing I do is try and get these numbers the same. So 3 and 8, they both go into 24. So I need to make them both 24. And what some people do is they just label this A and this B. And so what we're going to do here is we're going to multiply everything in equation A by 8 so that this becomes 24. So it's going to become 8A. And so we're going to times the 2A by 8, which will be 16A plus 24p, and 380 times 8 is 3040. And we're going to do the same with B, but this time we're going to times it by 3, so we're going to have 3b. And we're just going through everything here and we're timesing it by 3. So 9a plus 24p, which is good, that's what we wanted. And 780 times 3 is 2,340. So now we've got both of these the same coefficient. What we can do is we can eliminate going downwards. Now, if they are the same, the S in same is the S in subtract. If they were different signs, so if these weren't both positive, if one of them was negative, different, the D in different is the D in add. So here they are the same, so we are going to subtract. and we're going to subtract going downwards. So we're going to start off by doing, and I could just do a little line here to show what we're doing. So we're subtracting going downwards, and we're going to do 16a take away 9a, which will be 7a. 24p take away 24p, which is nothing, which is why we did that, is to eliminate them. And then 3040 take away 2340 will be 700. Then I can put my lines in, and all I need to do now is just divide both sides by 7, and I get a equals 100. So we know that apples cost 100, or £1. We need to work out what pears cost. So I just need to pick one of the equations. I'm just going to pick this top one here, and I'm going to write it out. But instead of a, we know that a is a pound, or 100 pence. So plus 3p equals 380. So that's going to be 200 plus 3p is 380. And then again, I'm just going to draw my lines down. And we're going to subtract 200 from both sides. So it's going to be 3p equals 180. And then we're going to just divide by 3 both sides. And we've got p equals 60. So a pear costs 60. Now we can check this by using the other equation there. So 3 times 100 is 300, plus 8 lots of 60 is going to be, what's that, 480? So that's going to be 780. So we know that we've got it right. So this question will probably need a Venn diagram just to make it a bit easier. So I'm going to draw a Venn diagram. You don't need to. If you can work out how to do this question without, you can do. But I think this is a really tricky question to do without a Venn diagram. So it says that they picked 2 activities. It was either painting, which I'll put as a P, and sport, which I'll put as an S. So let's start filling in the information it gives us. So 11 picked painting and sport, so that will go in the middle because that is painting and sport, and 11 didn't pick painting or sport, so they can sit on the outside. Now here's the problem. It says twice as many people picked sport than painting as one of their activities. So it's saying that the total number in, and let's just show it, the total number in the sport circle is twice as big as the total number in the painting circle. Now, what we can do is we can say, okay, so if the painting we label as X, then the sport will be 2X. But if you look, we've already got a number already in the sport, that 11 there. So in algebra, this will be 2X take away the 11 that we already know about. And the painting is the same. We know the whole thing is X. So what we're going to do is we're just going to take away the bit we know there, which is the 11, and it will be X minus 11. Now we know that there are 66 students in total. So what we can do now is add up all of the parts of the Venn diagram and get it equal to 66. So X minus 11 plus 11 plus 2X minus 11 plus 11, and all of that will equal 66. This is going to be some solving, so we're just going to put our lines in. Now here we've got X plus 2X, which is 3X. And if I put my tool right, there we are. And we've got minus 11 plus 11, minus 11 plus 11. Well, those just cancel out. So we're left with just the 3x equals, and then 66. We're going to divide that 3 both sides. So we've got x equals 22. So if we go back to our Venn diagram now, we can fill in the blanks. So instead of x minus 11 there, we've got 22 take away 11, which is just 11. Instead of 2x minus 11 there, we've got 22 times 2, which is 44, take away 11, which will be 33. So it says, find the amount that picked sport and not painting, which is this 33 here. You can complete a unique version of this paper by going to our onmaths site, OnMaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing.